In this video, you'll learn about Streamlit, a fantastic Python UI library that allows you to make interfaces very quickly. Now, I'll be showing you how to build entire websites in just a few minutes, and we'll go through all of the graphical components like forms, modals, charts, buttons, pretty much everything that you need. But not only that, I'm also going to explain to you the more advanced features of Streamlit, like the architecture and how things are rendered, so you can build more complex applications. This is going to be a great tutorial. It's going to show you everything you need, and you're going to see how easy it is to build websites and interfaces in purely Python. Now, with that in mind, all of the chapters for the different sections in this course will be available from the video player, so feel free to skip forward if something interests you more. You also will need to know a little bit of Python in order to understand this course, but don't worry, I won't be using any super advanced features. Now, with that in mind, let me quickly describe Streamlit to you. Now, Streamlit is a very simple yet powerful UI library that allows you to build entire websites using pure Python. So you don't need to write any HTML, CSS, or JavaScript. Everything you do is just in Python code, which makes it really great for people that want to quickly spin up a prototype or a very simple UI to interface with things like data science related apps. Streamlit has support for things like pandas, matplotlib, and numpy, and it really is geared towards data scientists, machine learning engineers, or people working with AI applications to build a really simple, really fast front end where they can interact with their applications. It has built-in support for things like graphs and charts and visualizing data, and you can do things like view the different rows of a data set, modify tables right on the site in literally just a few lines of code. Now, with that in mind, you can use Streamlit for pretty much anything that you want, and I find myself using it when I just want a fast front end to test something out for kind of prototyping or visualizing some data, but you could make an entire website with this if you wanted to do that. Of course, these apps can be deployed to production actually quite easily, and I think you're really going to see a lot of value in learning this framework, even if you just stick around for the first 20 or 30 minutes. And it's one of the first modules I've found that I've really been super grateful for in Python, because typically it's a bit difficult to build interfaces with just Python, and this kind of removes that barrier. Anyways, I'm excited to show it to you guys. I'm going to show you everything that you need to know. But before we get into that, I do quickly want to share with you a fantastic free resource that you'll want to be aware of. Now, this is a resource I put together in collaboration with HubSpot, who's the sponsor of today's video. It's completely free, and it's an entire guide on how to land a developer role in the world of AI. Drawing on my over a decade of experience, this summary covers the top programming languages to master and the most effective methods for learning them. It includes best practices for creating your portfolio and resume, along with recommendations for YouTube channels and other resources to enhance your development skills. I've left a link to it in the description where you can check it out completely for free. My favorite part of this is the long list of resources, including YouTube channels and websites that showcase fantastic free ways to improve your skills. This content is focused on helping you distinguish yourself as a programmer, especially in this AI era, offering essential insights and strategies to help you remain competitive in the developer industry. I'm thrilled to collaborate with HubSpot for this resource, and you can check it out for free from the link in the description. Now let's get started here by installing the different dependencies we need to work with Streamlit. So first things first, I've just opened up Visual Studio Code and I've opened a new folder called Tutorial. Now you can open anything you want, you can use a different editor, but VS Code is just what I'll use for this video. I've then opened up the command prompt or terminal, depending on your operating system, and what we're going to do is use pip to install Streamlit. So what you can do is simply type pip, install, and then Streamlit. Now along with Streamlit, we're also going to install pandas, numpy, and matplotlib. That's just because Streamlit works with these natively, and when you have them installed, it allows us to show a few more examples. So just for simplicity, install all of these different modules: Streamlit, pandas, numpy, and matplotlib. Okay, go ahead and press enter. That should install all of them for you in your Python installation, and then we're good to go. Now you can install this in a virtual environment if you'd like to do that, but you can also just install it globally, which is what I've done here. Now, for some reason that pip command is giving you issues, you can try the pip3 variant of that. You can also try typing python-m and then pip, or python3-m and then pip, and then install, and the different packages that I showed you. Okay, so now that we've got this installed, what we're going to do is write a very simple Streamlit app just to see how we run this, and then we'll start going through all of the different widgets, all of the text elements, and all of the different stuff you need to know about Streamlit. So what we're going to do is open up a new file here. So I'm just going to call this file main.py. You can name it anything that you want. And inside of here, we're just going to import Streamlit. So the typical import is going to be as following. We're going to say import Streamlit as st. We usually import this as st just so it's a little bit shorter when we're writing all of the Streamlit widgets. Then to keep things super simple, for now, we're just going to do st.write, and we'll just write something like hello world, and then make sure you save the file. Okay, so now that we've saved this file, we've got Streamlit, we've written hello world. Let me show you how we run the Streamlit application. So to do that, you can simply type Streamlit, run, and then the name of your Python file. You need to make sure you're in the same directory as it. So in this case, it's main.py. Okay, so this is working because my VS Code is already in the directory where my Python file is. So I go Streamlit run main.py, and then what this is going to do is run a web server for us. So let me bring over the web server here. This is the one. It's running on localhost port 8501. And you can see that right here. If you don't know what URL it is, it'll just show you here, and you can control and then click on that, and it'll open in your web browser, or you can just copy it and paste it in your web browser kind of URL. So what I'm going to do for the rest of the video here is I'm going to kind of split my screen. So I'm going to put the kind of finished application on the right side of the screen and then my VS Code on the left. And the reason for that is Streamlit supports hot reloading. What that means is that if I change something, so I go like hello world 123, and then I save this, if I go over to Streamlit and I simply refresh, you'll see that we get that updated code. So I don't need to rerun my Streamlit app every time I make a change. I can simply just refresh the browser, and actually I can go a step further. Let's change this to maybe 1234, save the file, and then I can go over here and notice it identifies that the source file has changed, and I can rerun this, or I can press on always rerun. Now, if I select always rerun, what will happen is every time I make a change and I save my Python file, it will automatically update in my web browser. So this makes development a lot easier because you don't need to constantly be kind of saving, refreshing, updating. As long as you change this Python file and just save the file, it will automatically update here in your user interface. Okay, so that's the absolute basics on Streamlit. That's how you run the application, and that's kind of the hot reload feature. That's what it's known as, which means when you make a change in your file, it will automatically update on your front end. Now, if for some reason there's some bug in your app or you're not getting an update, what you'll need to do is rerun the Streamlit command. So what you can do is if you're in this terminal window, you can hit Control-C. That stands for close, and that's going to stop the application or quit it. And then you can rerun the command again. So Streamlit run /main.py. If for some reason Control-C doesn't work, you can just close out of this terminal window. You can just quit it, open a new one, and then same thing, run the command, Streamlit run, and then you'll see it should open a new window for you. So just make sure you have one of these open at all times. Okay. So now let's start getting into some of the Streamlit commands. So here we use something called st.write. Now this is what's known as a magic command in Streamlit, and the reason it's magic is it automatically will write pretty much anything that you give it. So for example, if I want to write something like a Python object where I have a key and I have a value, and I save this and refresh, you'll see that it just automatically writes this in, and writes it kind of in a different format than just normal text. I can do something like st.write, and I can write in maybe a Boolean variable, and you'll see, let's just go always rerun here. It'll automatically add it as a Boolean. I can maybe add some numbers like 1, 2, 3. You'll see now it looks like some numbers, and pretty much any object that you write, whether it's a pandas data frame, a matplotlib a numpy value, something like a Python object, Streamlit will automatically determine how to write that based on its type. So that's what I'm showing you here. This st.write is kind of this magic command where no matter what you pass it, it's just going to figure out how it should write this and throw that on the screen. Now, obviously, there's some more granular control because it doesn't always write it exactly how you want it, but it supports pretty much any object. And based on the type you pass, it will kind of show you a different type of output here. Okay, so that's the st.write command, and you can use that again when you want to write something simple and you don't really care about exactly how it looks. Now, another thing you can do in Streamlit is you can simply just write an expression and it will automatically get written to the screen for you. So if I do something like 3 + 4 here, notice that I didn't actually st.write it. I just wrote 3 + 4, and now it's showing up on the screen as 7. And let me zoom in here a bit so you guys can see this a bit easier. If I do something like, hello world, it just gets automatically written to the screen for me. So this again is kind of known as the magic of Streamlit. You can literally just write any expression you want within the main line of the Python code, and it will automatically be written to the screen. And if you want to get more advanced, you can do something like hello world, if true, else by, something like that. And now if we change this maybe to say false, you see that it's going to write by. So we kind of have this inline expression, and you'll see that sometimes in Streamlit code. All right, so that is kind of the basics of writing with Streamlit. And again, this is referred to as kind of magic, like the write command in these expressions, it's called Streamlit magic. Now, what I want to talk to you about next is actually what's known as the data flow in Streamlit. So the way that Streamlit actually works is every single time something changes, so whether you're interacting with an element, whether you change something in your file, what actually happens is Streamlit will rerun the entire Python file. So anytime anything occurs that's going to kind of change the state that's happening on your page, you'll rerun the entire file. So what I'm going to do here is I'm just going to make a simple Streamlit button. So I'm going to say st.button, and here I'm going to go with press me. Okay, now what I'm going to do is store this in a variable. So I'm just going to say pressed is equal to st.button, and I'm going to print out pressed. Okay, now let's run our Streamlit application. And I want to explain to you what I mean here with the reruns because it's a little bit confusing. So when we start our application, what happens is this st.button kind of has a return value or a state, which is equal to false. Now that's telling us that right now it's not pressed, like it hasn't been pressed in the last run of this application. So when we print out pressed, we get false. However, if I press this button, you'll see that now we get true. So what's happening is we actually rerun the application once we press this button, and the state of this button changes to true, indicating that it was pressed. However, if I refresh this again, you'll see now this changes back to false. Okay, so what's happening is whenever some kind of event occurs that changes the state in our application, like a button press, we actually rerun the entire Python file. Now this button behind the scenes kind of has some state, which we're going to talk about later, and it's going to be set to true on the next rerun. So when I press this, what happens is we continue executing the rest of the script. So we print out, for example, pressed, which is equal to true or false or whatever it is. We rerun the script, and now the button's return value is equal to true, and then we handle the pressed action. I know, seems a little bit weird, but that's how Streamlit works. Okay, you rerun the entire application every single time. So even if I go up here and I print something like run, you'll see that, let's go always rerun here. We start by printing run, and then we print false, because now the state of the button is false, we haven't pressed it. When we press it, what happens is now we print run again because we start running, and then pressed is equal to true. So now we can handle whatever we want to do when you press the button in this rerun. Now it gets a little bit more confusing if we start adding more buttons. So for example, let's go, pressed 2 is equal to st.button, and we're going to say second button. And now we're going to print, and let's just make this a bit more clear. We'll say second, and then pressed 2. And then let's go first, and then let's do the quotation marks correct, and then pressed. Okay, so now you're going to see what happens is let's get rid of the run, and let's fix our colons, is that what we have is we have first is false and second is false. Now, if I press the first button, you see that first is true and second is false. But if I press the second button, you'll see that now the first button gets set back to false, and now the second button is true. The reason that happens is because when we reran the code, we had already changed this button to be equal to true previously. So on the next rerun, it's now equal to false because we've already handled the pressed event. So the state is a little bit confusing to understand here in Streamlit, but you need to just remember that every time something happens here where you're pressing a button, you're interacting with a widget, you're going to rerun the entire script. We're going to talk more about this later on, but that's kind of the core thing that you need to understand about Streamlit and the way you need to think about these applications running. So now what I want to do is I want to show you a bunch of different components, show you how we can make some really cool UIs and how we actually make something that looks obviously better than this. And then we're going to start getting into that more advanced architecture and understanding how to handle the different events, how to write Streamlit code properly. So just stick with me. I understand it's a little bit weird because this is kind of a different style of doing things than you might be familiar with in other UI libraries. Okay, so I've just cleared the screen here, and I'm going to start by showing you all of the different text elements we can use in Streamlit. Now, you don't need to memorize these, and if you ever need to look for a specific element, you can go to the Streamlit documentation. You can just Google Streamlit docs, and it's really clear and easy to find these different elements. But I just want to show you kind of what we can do so you get a sense of the different elements we have access to. So similar to things like HTML tags, if we want to do something like a title, we can simply say st.title. And then we can say something like super, simple title. Okay. When we save that, you see super simple title pops up. Now, as well as a header, as well as a title, we have a header. So we could say this is a header and save it. And then we get slightly smaller text. Okay. We don't have H1, H2, all of that kind of stuff, but we do have a bunch of other options. Now we also can do subheader. We'll say, subheader like this, and you can see now we have title, header, subheader. Obviously they're getting smaller. Now, as well as that, we have things like captions and markdown. So I could do something like st.markdown. And then if I wanted to render markdown text, which you might be familiar with something like a readme, I can do, this is, and then if I wanted it to be bold, this would be 2 asterisks and then markdown, exclamation point. And you can see now this is markdown. Now I believe if we want it to be underlined, we can do the underscores. I forget if that's actually something or not. No, maybe it's just 1 underscore. Let's see if my markdown skills. Yes, so this gives us italics. Okay, not underline, but you get the idea. So we can render markdown inside of here. If you're not familiar with markdown, don't worry, but it's just a way that we can kind of style our text pretty easily. Next, we're going to do st.caption. So if we do a caption, you can say, small text like this. And you see, let's just always rerun. Now we kind of get this small, more muted text that's in gray. And then of course we can do things like render code. So let's say I have a code example here, and let's make this a multi-line string. We're gonna go, define greet name. Okay, and then we're gonna say print hello, and then name. My quotation marks might mess us up here, so let's just go with single quotes. Then what I can do is say st.code, and then I can render my code example, and I could pass this something like the language is equal to Python. And now you can see that we're rendering Python code directly inside of here. So super easy to do this. Obviously, there's a lot of customizations and more options that you can pass, but generally you can make UIs pretty easily with these text elements. Now, last one I'm going to show you is the divider, or one of the last ones I'll show you. So if I go st.divider, you can see now we kind of get a nice gray line, so we can divide the UI a little bit, and that's about it. Okay, so those are our text elements, the core ones that you should be aware of. There's a few other ones obviously that we can look at, but these are kind of the main important ones. Now, what I want to show you is how we put images on the screen. So in order to put an image, what we need to do is make a folder inside of our main directory called static, okay? So it needs to be named static. If it's named anything else, this isn't going to work. And it needs to be in the same directory where your main Python file is. Now, inside of the static directory, you can simply put an image. So let me grab an image, and then I'll be right back. All right, so I just grabbed an image here, background.jpg, threw it inside of static, and I'm going to show you how we render that. Okay, so to render it, we're going to import the OS module. This is just how we're going to define the path to the image. And then we're going to say st.image, and what we're going to do is say os.path.join, and we're going to join os.getCwd. This stands for get the current working directory with the static folder, and then the name of our image, which is bg.jpg. Okay. Now there's a few other ways that you can render this, but this is what I found to be the most reliable. So you say st.image. This means, okay, I'm going to show an image, right? Notice if you highlight over this, there's a few options. You can, specify the width of the image, captions. There's a bunch of options for all of these things. I'm not going to go through all of them. Then we have os.path.join, which just means we're going to combine some paths. We're going to say os.getCwd. This means get the current working directory, so where our Python file is currently being ran from, and then combine that with the static folder and the bg.jpg file name. Notice when I do that, it now displays the image, and by default, we have the option actually to make the image full screen. That just comes in Streamlit. If we want to add options, for example, like the width, we can say, like width equals 50, and then we get a smaller version of the image. Obviously, it's a little bit distorted now because it's just so small and we're using so few pixels, but you get the idea. Okay, so that's how you show an image. Just make sure you put it inside of that static folder, and then you can render it like this, and you can mess around with some of the options like changing the size. All right, so now that we've looked at some of the text elements, I want to show you some of the data elements. So just like we can render text, we can render data, and we can do that using things like pandas data frames, if you've ever seen those before. If not, don't worry too much about them, but I do just want to show you a quick sample here. Okay, so I've written a simple Python script here just to kind of demo this so I don't have to write all of it out. You can see that we've generated a simple title, which we're seeing right here, and then we have a data frame section. So I've made a subheader for the data frame, which is this, and then I'm rendering a pandas data frame. So I've created this. It's kind of just like a table, right, or kind of like a chart. And I have name associated with a bunch of names, ages, occupations, and then what I can use is st.dataframe. This is used specifically for pandas data frames. I can pass the pandas data frame to it, and now you can see I get a nicely formatted data frame. And actually what I can do is make this larger. I can search through it. I can download it. These are just default options that Streamlit provides. Okay, now I can also sort by columns if I want to do that. It's just provided by Streamlit. Okay, next we have something like the data editor section. So here we get the same thing that we had before, except we can actually edit this data frame. So what I'm able to do now is I can go in here and I can change the name to like Joe, for example. And if I do that, what will actually happen is this variable will get edited with this new data frame. So if you wanted to, for example, edit the data frame and then save that in a database, you could do that. So if we go here and we say, print editable data frame like this, let's just go here and have a look at this. You can see that we get the updated data frame because I've changed this variable. If I change Bob to be, for example, Tim, and I hit enter, you'll see now that when we print this out, we now get Tim. And keep in mind what's happening here is we're rerunning the entire script, and then this is getting updated with that new state from our UI. So this is, again, quite useful if you want someone to be able to kind of visually modify something like a data frame or a table. Okay, now we also have the option to just render a static table. So if you don't want to have all the options for sorting and viewing and interactability like we have with the data frame, you can just render a simple table. And here you can see that we get the table. Okay, next we have something like the metrics. So if you want to print out some information about different tables, what you can do is use this metric. So what I'm doing is saying, okay, I want to print out the total rows. Then the value of this is going to be the length of my data frame. And then what it does says total rows, and then gives me kind of a big piece of text here, which is an important piece of data from, for example, this table. It can be for any table you want, but this is just a metric label that you can use. Same thing with average age, and we're just rounding the mean age from our data frame, and you can see that right here. Now, as I showed you before, we also have the ability to view kind of JSON and dictionaries. So you can see we get this nice like collapsing view when I print out something like a Python object using st.json. Now, if I don't use JSON and I just use st.write, we're going to get the same thing because by default, it's going to treat a Python dictionary like JSON and then write JSON for us. But if we want to specifically say, hey, let's write JSON, then we can use st.json. Now that's actually exactly what's shown here when we're doing the st.write command, but you guys get the idea. So again, please don't feel like you need to memorize these. I just want to show you a bunch of different options so you get familiar with some of the UI components. And don't worry, soon we're going to start building out some sample UIs and talk more about kind of the different widgets and elements. Now what we're going to do is look at some form elements, then we'll look at some chart elements, and then we'll get into that more advanced architecture, dealing with widgets, handling events, etc. So actually I lied, we're going to look at the charts first because that makes a little bit more sense. So what I've done here is I've imported matplotlib, numpy, and pandas, as well as Streamlit. And I've just written a simple demo here that shows you some of the different charts that we can render. So for example, I can use something like a pandas data frame, and I can generate some random values and associate those with columns A, B, and C. And what I can do here is create something like an area chart. So what I've done is said, okay, st.subheader area chart, and then I'm rendering an area chart from this chart data. And you can see we get an area chart popping up here with our labels A, B, and C. Notice I didn't need to pass any options here. I didn't need to define the scale. It just rendered it probably exactly what I'd like. And you can see here that I can kind of zoom in and interact with the chart, make it bigger. I can click on this and save this as an image. This is just all built into this default component. Now, if we go down here, we can do something like a bar chart. So that's what you can see. So right here, we say st.barchart, and then we've got a bar chart popping up. This is kind of what it looks like. We have the ability to do a line chart, which is this one right here. We can do a scatter chart or a scatter plot. That's what I typically call it. So you can see that we've rendered some random data points for X and Y here. And then we did our scatter data. And now we have this popping up in the scatter chart. Okay, to render that, you use this. Next, we can do something like a map. So like if you want like a geolocation map, you can do that. So we said st.subheader map. We generate a bunch of random coordinates based on their latitude and longitude, and then we can map that using st.map. Now, again, the point here is not to memorize all of this. I'm just trying to kind of show you the options you have here in Streamlit, so you can look into these more specifically if you want to use these widgets. We are going to build some sample UIs and whatnot. I just want to give you a sense of kind of what's possible. Then we can do something like a pie plot chart. So if you're already familiar with, for example, matplotlib, you can create a matplotlib chart like you normally would make it, and then you can just plot that on your UI. So we say st.pyplot, and then we just take this figure that we've generated like we would generate any matplotlib chart, and we can just render that on here as an image. Okay, that is charting. Now I want to go over to forms where there's a lot more to talk about. Okay, so what I've done here is I've just made kind of a sample form that shows you a bunch of the different input elements that we have. And then after this, we'll write one from scratch. So you get the hang of how the forms work. But again, I want to show you the different components. So you see here that I have a Streamlit form demo. I have some text inputs. So something like, I can enter my name here. We can provide feedback. Hello world. We can do something like enter our date of birth. So we can go back here to, for example, let's just do like this 2014, whatever. We can change some time to something like this. We can select out of some radio boxes. We can select our gender. We can move a slider and select some range. And we have things like checkboxes. We also have a submit button for this form. So if I go here and press submit, you'll see that down here it says, thank you, Tim, date of birth, preferred time, option, all of this stuff just kind of shows it to us on the screen. We also have links. We have a button that can, for example, download data for us. We have another button where we can just press it and it gives us some output. Just showing you a few form elements that we have. There are more, but here are a bunch that you should be aware of. So if you look inside of this code, you can see that we have, for example, text input, text area, date input, time input, radio buttons. Notice that we just specify which radio buttons we want. We have select boxes, something like male, female, other. We have a slider, and we can specify the different options we want to have on that slider. We have some check boxes here. Okay, so if we go to check boxes, you can see they're not necessarily in a group, but they're just two different checkboxes we can use. And then we have a form submit button, which is actually going to collect all of these elements and submit them all at once. Now, one thing to know about the forms, and you can see we've provided this with the with statement here, is that this kind of avoids the issue of constantly rerunning your script anytime a widget changes. When you put something inside of the form, like you've seen here, Streamlit will actually collect all of these inputs before it reruns the application. So what will happen is only once you press the submit button inside of the form will it collect all of this data and then rerun the app. So you're not going to have, constant reruns every single time you're updating something within one of these forms. There's more to talk about with that, but for now, let's clear the screen. Let's write a form from scratch and let's understand these concepts better. Okay, so let's write a simple form. So we're going to start obviously by importing Streamlit as st, and then let's do a title for the form. So we're going to say st.title, and we can say user information form. Okay, when I do that, you can see it pops up on our screen. Next, we are going to define a form. So we're going to say with st.form. Now you have the option here to specify something known as a key. The key is how we can kind of uniquely identify this form. So I can say something like user underscore, if we can type this properly, user underscore info underscore form, but you don't need to pass the key, but it's just typically good practice to give this a unique identifier. Okay, after that, we can start writing some different inputs. So if we wanted a text input, we can say st.text underscore input is equal to, enter your name, for example. And then let's do like a number input. So let's say st.number input equals enter your age, like that. Okay, so for now, let's just do two simple inputs and let's store their values in a variable. So we're gonna go with name is equal to this and age is equal to this. Okay, then let's go down here and let's print the name and the age. Okay, now also it's giving us an issue here. It's saying this form has no submit button, which means the user interactions will never be sent to the app. So you need to add this. So let's add this in, which is our submit button. Now that's an important point. You need to have a submit button inside of your form. That's just a required, mandatory thing. You need to have this in order for the form to function properly. Okay, so we're just going to add this button. Okay, So when we've done this, you can see now that we have this in our app. And what I want to show you, if I bring up my console here and I look down here, is that if I start typing something like hello Tim, notice that this doesn't immediately rerun my application. Now, based on what I told you previously, every time something happens, like we interact with a text element or we press a button, for example, we're going to rerun the app. Now, the form kind of overrides that behavior. It makes it so that every time we make a change here, we don't need to rerun the application. Instead, what will happen is it will wait until we press this submit button, and then it will submit all of this state. So if I press submit, now you'll see that it says hello Tim and it prints this out, but only on the submit button press. Now that's an important point because look what happens if I take these elements outside of the form. So if we delete this and let's remove the submit button and we save this now, let's just refresh to kind of get a clear screen and let's start entering our name. So we say like hello, for example, and you can see that when we do that, it immediately updates and prints out 0. Then I can update this, and you see every time I change it, it's rerunning and updating our app. So it's not clearing what's in the previous kind of input box here, but every single change is rerunning the application, and obviously we don't really want that because we're having so many different reruns for every single input change. So what we can do instead is what we had before. We can group these elements inside of the form. Let's save. And now when we make an update, you see that it's not rerunning our app every single time. It's only when we press that submit button. Okay, so the form kind of handles its own state internally. Then once we press submit, it reruns the app, and then we can handle all of these different inputs at the end together rather than having to manage each of them independently on every single app rerun. So anyways, let's continue here and let's make a slightly more complex form. So rather than having name and age, I'm actually just going to make a Python dictionary to store our values. So I'm going to say form_values is equal to a Python dictionary. And then in here, we're going to specify the different values we have in our form. So we're going to say name is none, height, let's go with none. Let's do another one. Let's go maybe gender here. Okay, if we can type this correctly. Let's go with something like date of birth. Okay, let's make that none. And then lastly, let's go with location. And same thing, that can be none. Now what I'm going to do is just use these dictionary keys. So I'm going to say form values at name is equal to this. We're actually going to change this to be the height. And let me fix my indentation here. Okay, so we're going to say form_values at height is equal to this, and let's make it a little bit bigger so you guys can read what's going on. We're going to say enter your height. Okay, and we can specify that this is going to be in centimeters. Then we can say form values at gender is equal to st dot, and we can do a select box. And for the select box, we can say gender, and then we can pass our options. So we can say male and female. Okay. Then let's go form values and let's go date of birth. Okay. And we'll go st.date_input. And we will say enter your birth date. Okay. And do we want to do anything else? Actually, I'm going to get rid of the location because I don't think we really need that one. Okay. So that is good. Now we have our form values. And what I want to do is before I allow the user to submit, I want to make sure that all of these values have actually been entered. So what I'm going to do is say submit_button is equal to this. And I'm going to say if the submit button is pressed, which is kind of how we can handle this, I'm going to check if all of the input fields are filled in. So I'm going to say if not, all, and then this is going to be form values dot values. What I'm going to do is say st.warning, and I'm going to say please fill in all of the fields. Okay, so let's handle this actually. What I can do now is we have the form submit button. Okay, we can give this a label. So let's make this submit. Let's just refresh to make sure this is kind of all cleared here. And I think everything is running. And let's start filling in some values. So let's go name, Tim. Let's enter our height. Maybe if we want to change this, 175. Okay, male, good, and then birth date. You'll notice it only goes back to 2014. I'm going to show you how to change that in a second, and then we can press submit. Now, when we press submit, we don't get anything. The reason for that is we filled in all of these fields. But if I remove, for example, Tim, and I press submit, you see that I get a warning inside of the form and it says, please fill in all of the fields. Okay, so once we press the submit button, it did this. We gathered all the values. We saw that one of the values was none or an empty string, so it gave us that warning. Okay, hopefully that makes sense, but I'm just kind of showing you how you can handle this submit. Now, obviously, what we'll probably want to do is give the user some output if they submit this properly. So let's do an else statement. And if it's going to be over here. If this is not the case, meaning that the form was successfully submitted, we're going to show them some balloons. So we can say st.balloons. That's going to throw some balloons on the screen. We can say st.write. And if we want to write something like a markdown header, we can do 3 pound signs. And then we can say maybe like info. And then we can say for something like key, comma value in the form values dot items. This just gives us all the items in the dictionary. We can say st.write, and we can write an f string and say something like key, colon, and then value. Okay, so this is just me very quickly looping through all of the values in the dictionary and just printing out all of their kind of keys and then their value. So now if we go here, we're gonna do always rerun, so this keeps updating. If we submit, notice we get this because we don't have Tim. And if we change this to Tim and we submit, you see that it gives us some balloons and then it gives us our information, Tim, height, gender, date of birth. Okay, so that is an example of a simple form in Streamlit. Point was just to kind of explain to you what happens when we wrap this in form versus when we have the elements outside of the form, and what happens kind of with the submit button and how we handle that. Now, keep in mind, this form is kind of handling all of the state itself. And what happens when we press the submit button is we do actually rerun the application. So what really goes on here is we fill in all of these values, we press the submit button, and then right when we press this, the if submit button is actually equal to false. The reason for that is in this current run of the code, the submit button has not yet been kind of changed to true, like this is not yet returned true. So then on the rerun of the application, what happens is now submit button is equal to true. So we go here, we see that this is true, and then we handle the form submission. Hopefully that makes a little bit of sense, but to kind of show this to you, we can say print, say in if, and we can do a print here, and we can say after submit. And I just want you to really understand the data flow here. All right, so I just reset this so the example's clearer, but you can see that immediately it says after submit, all right? Then what's gonna happen is I'll submit the form, and you see it says after submit and then in if. So we had already ran the after submit, and then when I submitted the button, so I pressed the button, what happened is this ran again, and then we ran the in if. Now that's telling us that we reran the entire code because this print statement got triggered again. And it wasn't until this was triggered a second time on the rerun that we entered inside of this statement because now the submit button was equal to true. Okay, so that's how the form works. When you press the submit button, it does the rerun, and then inside of the form, I mean, we could have done this outside as well, we can handle the different values. And then since we're writing stuff within the form, that's why you see the warning in the form. That's why you see the values inside the form. If we took this outside of the form, like this, then what would happen is we would write it outside of the form. Okay, so hopefully that makes a bit of sense. So the location where you write things is important, and we kind of nested that logic inside of the form, so it's written inside of this border, but if the logic was outside of the form, then it would be written below this outside of the form element. Oh, and last thing before I forget, with something like the date input, you saw that if I click on this, it only goes all the way back to 2014. So if you want to change the dates that are acceptable there, you can do something like this. You can say from date time import date time. This is built into Python. You don't need to install it. And then you can set the different dates. So I can say something like min date is equal to date time. And then I can specify this is like 1990 which is January 1st, 1990. And then I can say something like the maximum date is equal to, and then this will just be datetime dot now. So that just gets the current date. And then if I go to my date input, I can say that the max value is equal to, and then I can do the max date. And then I can say the min value is equal to the minimum date. I think those are the options at least. And then if we rerun this, you'll see here, if I go to the date field, now I can go all the way back to 1990, and then the maximum date is today's date. Okay, so just showing you a few options you can pass. Obviously, there's a lot more, and typically when you highlight over them, you can kind of see the different options that you can pass here to these input fields. Now let's do one more form example that's a little bit more complex and then move on to things like caching, state, etc. All right, so I've just thrown another example on screen here because I want to show you some of the issues that can occur when you use forms because of the execution flow of Streamlit. So you can see that I've imported Streamlit, I've imported datetime. We have kind of a similar form to what we had before. Now, my idea with this form is what I want to do is I want the user to be able to enter their birth date, and then I want to give them kind of a custom message telling them how old they are, like what their calculated age is based on their current birth date. So I have that logic written in here. I say, okay, if the birth date, so if we have some value here, we're going to say the age is equal to this, and then we're just going to check the current month to see if they're actually that old or not. Otherwise, we're going to subtract 1, and then we're going to write their calculated age. Now, let's see what happens when I try to use this form. Let's just get a clean refresh here. Let's enter my name, so Tim, and let's enter our age. Okay, so we can go all the way back to 2000. I'm not going to enter my real birthday, but you see that this doesn't get updated. So even when I change this, nothing's changing here. Now, the reason for that is, again, when we use the form, we defer the rerun or the execution of the logic inside of here. So we still show these kind of input widgets and we keep track of the state that the user has inside of them, but we do that without rerunning the application. So what's happened is I'm checking if birth date, but if birth date only becomes true when we submit and we have a rerun. So if I submit this now, you see now this gets updated and it says our calculated age is 23 years old, but we only saw that because of the submission, and that's when we forced the rerun, which then changed the value of this variable, which allowed us to handle the calculation. So you might be asking yourself, okay, well, like, what does that mean? How do I actually fix this? I'm about to show you in the next lesson how we fix this using something called session state, but the point is that we can't do this like dynamic updating of different components inside of the form because it requires the rerun. So really what you would need to do here is you would need to take these elements outside of the form and you need to use something called session state, which we're going to be looking at if you want to have this kind of dynamic updating. So sometimes you have one form input that maybe changes another form input. And again, with Streamlit, you can't do that when you use this inside of the native forms because of that deferred execution. So that's why I really just want to nail this into your head, how the form works. Only after the submit you trigger the rerun, and that's what then updates the variables and allows you to perform like a dynamic update or calculations of logic. So if you want to do that, you got to move it outside of the form, and then you don't have that advantage of deferring all of the reruns. Okay, anyways, let's go into session state now so you can really understand this better. So I've got a simple example on screen here of a counter in Streamlit. Now it seems straightforward, and this might be naively what you try to implement to build a counter, but I want to show you the issues with this. So obviously we import Streamlit, we set a counter variable equal to 0, and then we're going to write out what the value of this counter is. We're going to check if the button was pressed. If it's pressed, we're going to say counter plus equals 1, then we're going to write to the screen. Okay, otherwise we write counter stays at, and then whatever the value of the counter is. So you would think, that if I press this, it's just going to keep incrementing our counter. But notice that it doesn't do that. Every time I press this, the screen just stays the same. Now, the reason for that is the reruns and the execution here that we have are kind of the data flow within Streamlit. So what's actually going on here is when I press the button, we immediately rerun the application. So button is pressed. Before we even do what's inside of here, we rerun the whole app. So that means we come up here and counter is equal to 0. So we set counter equal to 0. So again, press the button, immediately come up here to counter equals 0. Then we write the value of the counter, which is, well, 0. And then this now is equal to true because after the rerun, this button state has changed. So now it's equal to true. So we then add 1 to the counter, and then we write the new updated value of the counter, which is 1. Okay, so we do get 1, but we can never get past 1 because every time I press this, we're resetting the counter back to 0 at the top of our program. So you might be asking, how do I fix this? Well, I'm going to show that to you, and we're now going to implement something called session state. So let me bring in a new example that uses the state, and we'll talk about how that works and how we can actually implement something like a simple counter. All right, so I've just written another simple example here where we've now implemented the counter using something known as session state. Okay, so session state is something that we can use to store values within the same user session. Now, a session is specific to each user and specific to kind of the instance of the web browser or the tab that they have open. So anytime I refresh the web browser by physically pressing the refresh button, not rerunning, but refreshing by actually reloading the page, the session is going to change, or it's going to be reset. And same thing for different users. Like if someone else signs into the website, they have a different session. Now, this is slightly different than other web sessions you might be familiar with. So each session is per user, per run, or per instance of the kind of web page. So again, it doesn't change on the rerun of our Streamlit app, but it changes if the user refreshes the page manually, okay? So keep that in mind. Per user, per kind of refresh cycle of the web page. I don't have a more elegant way to say that. Okay, so what we're able to do is access this st.session_state. Now within here, we can just make different key value pairs. So in this case, we have something like a counter, and we can assign this equal to 0. Now the session is going to persist on all of our reruns. So this is what we can use rather than say a standard Python variable, which is going to get reset every single time we kind of see that variable definition line. So what I'm doing at the top of my program is I'm checking if this counter key is in the session.state, which really acts just like a Python dictionary. Now, if it's not inside of here, I'm going to say st.session_state.counter is equal to 0. Okay, so I'm going to set the counter equal to 0, but that's only if the counter doesn't already exist in our state. Then I have my button. So I have a button here for incrementing the counter. If this button is pressed, what's going to happen is we're going to add 1 to the session state counter, and then we're going to write the updated value of that counter. Okay. Then we have a reset button. All the reset button is going to do is simply reset the counter back to 0. And let's just get rid of this counter did not reset because we don't really need that. Then at the bottom of our program, we're going to write the counter value. So if I refresh this here, we see the counter value is equal to 0. And when I increment the counter, it says counter incremented to 1. And now the counter value gets set to 1. Now, if I run this again, you can see that we can go up as much as we want. We can reset, and this works. Now it's working because we're updating the session state, not a normal Python variable. So let's run through the execution flow. On the first run, so before we've done anything, when we refreshed here, we said counter is not in the session state, so we've set the counter equal to 0. Now, if we press the button, so we press increment counter, what happens is we rerun the application, so immediately rerun when the button's pressed. We come here, we check if counter is in the session state. It is, so we don't reset it because it already exists there. And then we see that this now is equal to true. So we go in here, we update the counter to add 1. We write this line, so, counter is incremented. And then we come here, we check if the reset button was pressed. It wasn't pressed, so we don't reset this. And then we write out the new counter value. Okay, then if we press this again, same thing. What happens is we rerun immediately. We do not do this because counter's already here. We then have this equal to true. So we add 1 to the counter gets incremented, and then we write the new value. Perfect. Now let's switch this a little bit and see what happens if we put this write statement up here before the button. Okay, so let's refresh this now manually. So now we're in a new session. We've cleared out the variable, and let's increment the counter. Now notice the counter value stays at 0, and then we get counter value incremented to 1. And we're always lagging behind by 1. Now, the reason we're lagging behind by 1, again, has to do with the reruns. So again, when we press st.button, what happens is we immediately rerun the code. So we come up here, we execute this line, then we write out the value of the counter, which on the first press of increment is still 0. Then this is equal to true, and then we increment the counter. So because we're incrementing the counter after we're writing this line, what's happening is we're writing the old value of the counter before we get into this if statement to do the increment when we've rerun the code. So I know I'm showing you a lot of examples here, but I just want to illustrate that where you write, for example, a state update matters, because if it happens before the update actually occurs, the way that this reruns means you're going to be showing the old value of the counter. Okay, so you would need to take this and just make sure that you put it below this line right here, or this one for that sake, where we're actually updating the value of the counter. Now, obviously, you can have multiple different values in session, but this is kind of the most basic example I could show you, right? Holding a counter, That counter is some numeric value, and I show you how we add to the counter and reset it, but you can do this with literally anything. And again, this now will persist across your app reruns. So now we're moving on to callbacks. Now callbacks are functions that you can trigger when a button is pressed or when something like an on-change event occurs, and they're important to understand in comparison to something like basic state or reruns and kind of how that works in the data flow and in the execution. So what we're going to do is build a form here. I'm going to build essentially a version of a form that doesn't work without callbacks, and then I'm going to show you how we add the callbacks so you can see their value. So what we're going to do is start by adding a step here in our state. So we're going to say if step is not in st.session_state, then what we're going to do is say st.session_state.step is equal to 1. Now we're going to copy this and we're just going to do the same thing except for this info key. So we're going to have two pieces of state here, one to store our personal information and one to store the step in the form that we are on. Okay, so our info is going to be equal to an empty dictionary. Now what we're going to do is we're going to check, we're going to say if st.session.state or session_state, sorry, if we can type that properly, dot step is equal to 1, then we want to render the first part of our form. Otherwise, we're going to say if st.session_state.step is equal to 2. This also could just be an else statement. Then we'll render part 2 of our form. So in the first part here, we're going to say st.header, and we're going to go part 1. And then for this, we're going to make this part 2. And we can make this like review, and we can say something like info. Okay, now inside of here, let's just ask for something like the user's name. So we can say name is equal to st dot, and this is going to be text underscore input. And for the value of this, we're going to call this name, that's going to be the label, and then we're going to say value is equal to st.session_state.info.get. And we're going to get the name, and then the default will be an empty string. So I'm just showing you here how we can actually manually set the value. We're making this equal to whatever's stored inside of the session state. Okay, so then what we're going to do is, let's just have a button. So we're going to say, actually st.button, and then next. And we'll say if we press this button, then what we want to do is update the state. So we're going to say st.session_state.name is equal to the name, and then we want to make the step go to 2. So we're going to say st.session_state.step is equal to 2, so we move on to the next step in our form. Great. Now inside of part 2, what we're going to do is just have like please review this information and make sure it's correct. So we're going to say st.subheader. We're going to say please review this. Okay, then we're going to have st.write, and what we can write is an f string, and we can do something like, asterisk name is equal to st.session_state.name. Okay, and actually let's just do .get or .info.get, sorry, and then we'll get the name in case it doesn't exist, and then this will be an empty string. And I think I need to actually make these single quotation marks because sometimes when you embed double quotes inside of double quotes, you get an error. So I'm just going to kind of fix these here. Okay, we could have other information as well, but for now, we're just going to display the name, and then we're going to have some buttons. So we're going to have if st.button, okay, and this is going to be submit. Then what we will do here is we'll say st.success, and we'll say great. And then we can say st.balloons like this, and then we can reset our personal info. So we can say st.session_state.info is equal to this. So kind of clear the form for us. And then otherwise, we're going to say if st.button, and this button is going to say back, then what we want to do is go back to the previous step. So we're going to say st.session_state.step is equal to 1. Okay, let me zoom out a little bit. What we're doing here is having two pieces of state, one for storing the step in our form, one for storing the user's information. Now we could store more than just the name, but I'm just doing that right now for simplicity. What I'm saying is if we're in the first step, then what we're going to do is render part 1, we're we're going to ask for the user's name, and then we're going to have a next button. And if they press that, we're going to update the name. So this should actually be .info.name. And then we're going to make the step go to 2. Then we have step 2. For step 2, what we're going to do is render part 2. We're going to kind of give them the ability to review this. If it's good, they can press submit. Otherwise, they can go back and they can change that data. Now, this seems like it's going to work, but watch what happens when I refresh here. So I'm going to have part 1. I'm going to have my name Tim. Now, if I press next, notice that first of all, we got an issue here. It says dict object has no attribute name, so we can fix that in 1 second. But also notice it didn't move us to the next step. So let's first of all just fix the problem here. It's saying session.state.info.name is equal to name. So we probably just need to make this like that. And I think now that should fix the problem for us. So let's go Tim and press next. And notice when I press this, now we don't get any error, but nothing happened. We didn't move to the next step. We actually need to press it a second time before it moves us over here. And now we have the state, but notice we get the same thing. If I press back, it doesn't move us back. It's rerunning, but we're not going back. We actually have to press it a second time before it moves us back to this page. So why is that happening? Well, the reason it's happening is because of how the reruns are occurring. So what I've done here, right, is I've said, all right, when the button is equal to true, we're going to update the name in our session, and we're going to update the step. However, this update here happens after we've already entered this if. So what's happening is when we press the button, we immediately rerun. So we rerun, we do all of this. The step has not yet been updated. So the step is still equal to 1. So we go inside of this if statement. Now what happens is because this button is now equal to true, we update the name and we update the step. But we're not going to see that update until we actually rerun this app. The reason for that is we've gone inside of the if statement, and now we're not going to look in this elif because we're already inside of this if. So what we could do is we could change this now to just simply be an if rather than an elif. So after the rerun, this will trigger, this will update, and then we can show session 2. But you're going to see there's still some problems with this. So if we refresh and we enter Tim and we press next, now notice part 1 still shows up, but now we're getting part 2 as well. And if we press back, you can see that now it's just showing part 2. So this obviously isn't a fix to our solution. And again, the reason that's happening is because of the reruns. To clarify, what happens? We press button, we rerun the whole thing. So we go into here because the state is still equal to 1. Now, and only now on the rerun, do we go inside of here and we update this information. So now the step is equal to 2. So we're able to go inside of the if and render that next component, which you see here. Okay, so that's great. But then the same thing happens when we press back. When I press back, what happens is we rerun the application. So what happens is we do all of this. The step is now equal to 2 because we haven't yet reset it. So now we show this form again, but we're not showing this one this time. And then we change the session step to be equal to 1. But again, it's not until we rerun this that are we going to see this if statement again, so we can then go back into part 1. So how do we fix this? Well, the way we fix this is using callbacks. Ideally, what we want to do is we want to perform this update operation before we start rendering all of the stuff on our screen. But if we put it inside of an if statement, it only happens once we reach that block of code, which could be at kind of any random point in our program. So rather than performing the update here, we're actually going to move this into what's called a callback, which is going to fix this problem. So what we can do is define a function, and we can say, go to step 2, for example. And what we're going to take here is simply the name. Now we're just going to take this code, and we're going to paste this inside of our callback. Okay. Now rather than having this if st.button, we're going to change this line to call this function. So we're going to say on_click. This is what it's called. Okay, on_click is equal to, and then we're going to go to step 2. Okay, now I need to pass some arguments to this. So I'm going to say args is equal to, and I'm going to pass a tuple, and inside of here I'm going to pass a name and then a comma. Now whenever you're passing a tuple and you have only one argument, you need to put a comma after the argument so that Python knows that this is a tuple rather than just a set of parentheses surrounding a variable. I know that seems weird, but whenever you're passing one argument, it needs to look like this. So what I'm doing now is I'm implementing a callback. Now the way that the callback works is it's ran before any other code on the next rerun. So same thing. When I press the button, we immediately rerun all of our code, but before we do all of this, this function is executed. So that means we update the step and we update the name before we start executing the code that's in line here. So now we'll immediately render step 2. So when I press next here, let's just refresh and do this again. You'll see that we immediately go to part 2 because the callback is triggered before anything else. Okay, so rerun occurs, callback is triggered at the very top, very beginning of our, our rerun. So now the state is updated before we start reading all of this. Now, obviously we need to fix this for back still because that's still not working. So let's do the same thing for back. So let's make another callback function. Okay, say define go to step 1. Okay, this doesn't need to take any arguments and we can just set the step to be equal to 1. So now for my back button, same thing. I'm going to remove this and I'm going to add the callbacks. I'm going to say on_click is equal to go to step 1. Okay. And now if we refresh and I go Tim next, and then I press back, you see it just brings us back to the step. So we don't need to press it 2 times. Great. Now in terms of the st.button here in the submit, it's going to be kind of the same issue here, depending on what we want to do. But if we go next and we press submit, this is still fine because we want to stay within step 2, and we've then reset the state info. So now when we go back, you can see the name is reset. So you could kind of implement a callback for this button, but in this case, we don't need it because we're not trying to change something immediately on the next rerun. In fact, we actually want to go inside of this block so we can then show success, show the balloons, etc. Okay, so that's the callback. Keep those in mind. Super important. If you want to do something at the beginning of the rerun, you need to use that callback. The callback is triggered before anything else. Okay, now that we understand that, let's move on and talk about layouts. Okay, so let's get away from some of the super complex stuff and have a look at layouts. I won't spend too much time here, but I want to teach you kind of how you can separate different components out and lay them out in different rows, columns, sidebar elements, etc. So if you have a look at the right side of my screen, you can see that now I kind of have some things in a layout that might be familiar to you if you use something like Flexbox in CSS. And you can see that, for example, we have different tabs, so kind of like a tab group here. We actually have a sidebar that you can open up where you can put elements there. And then we have different columns. So we're able to kind of add multiple columns and have that kind of Flexbox-like layout. And you'll see that this is dynamic. So as I kind of move things around the screen, if it's too small, it'll shift over here and it gets bigger and smaller. Okay, so anyways, let's move this over a little bit. Let's just have a look at some of these elements. So for example, if you want to write something in the sidebar, which is this right here, then you can just write st.sidebar and then the name of whatever element you want to put there. So if you want to put a title, you write st.sidebar.title. If you want to just write normal text, you just use write. You can place elements like sliders, buttons, text, whatever you want. If you want to do a text input, then you can just place that in the sidebar. So this works the same as the main kind of element or the main canvas. You can just put things in the side. So if you want to have some navigation or you want to have maybe a login or something, or you want to kind of hide it in the sidebar, you can do that here. Okay, now in terms of the tabs layout, this is pretty straightforward. If you want to make a tab group like this, you can say tab 1, tab 2, tab 3, or you can make like tabs and then you can access them with 0, 1, 2. So anyways, let's go tab 1, tab 2, and tab 3 like we had. And then you can make this equal to st.tabs, and then you can give each tab a name. So we've called it tab 1, tab 2, tab 3. Change those obviously to whatever you want. Then you can say with tab 1, with tab 2, with tab 3, and then inside of this, it's called a context manager. You can write anything that you want to appear in those tabs. So for tab 1, we're writing tab 1, tab 2, writing tab 2, tab 3, writing tab 3. Straightforward. That's how you kind of handle these different tabs if you want to have that type of layout. Now, this is probably the most useful one, the columns layout. So a lot of times you want to have multiple things in the same columns. So you can do that by using this column layout. So if you say st.columns, this is actually going to create a row for you and then give you different columns that will be laid out just like a Flexbox column would be. So I'm able to now have, with column 1, I'm writing the stuff I want in the first column. With column 2, I'm writing in the second column. If I wanted to add a column 3, I just do column 3, change this to 3s, grab this, change this to with column 3, and then make this column 3, and then just refresh here. Oops. If we refresh, you can see now we get 3 columns popping up on the screen. Okay, Next, we have something like a container. So if you want to have kind of like a bordered container like this, then you can say with st.container, you can write some text inside of here. You can disable the border, obviously, if you want to do that by removing the border. And there you go. Next, we have this empty container. Now, this is kind of a placeholder where we can render dynamic content. So for example, right now we said placeholder.write, and then we're writing this inside of here. But then what I'm able to do is if I press this button, I can override what's inside of here, overwrite what's inside of here. So if I press on update placeholder, notice that it doesn't actually add this to the bottom of the placeholder. It just changes what's inside of it. So we used to have this content, but then I pressed the button, we reran, and then here we wrote the content of this placeholder has been updated. So useful for dynamic content when you want to change, for example, a message that you're showing in a box. Okay. Next, we have an expander. So sometimes you want to have kind of like an expander box. So we say with st.expander, and then we can write multiple pieces of content here, and then it gives us that kind of drop-down view so we can expand this and see what we're getting. Now, we also have things like tooltips. So for example, I can say hover over this button for a tooltip, and then we can do a help message for the button. So if I go here, you see this is a tooltip, or pop over on hover, and then yeah, that's it. you get kind of a pop over. Next thing here, if I enter something, so like I go, hello world, and then you just press enter here, you see that we get, you entered this in the sidebar, hello world. Okay, so just kind of grabbing that sidebar input, just showing you how that works with this input button up here, input text up here, sorry. Okay, that's really it for layouts. Obviously, there's more stuff you can do. There's a lot more customizations, but I wanted to show you the basic components, so at least you're familiar with things like column layouts, expanders, tooltips, all of those kind of frequently seen elements. All right, so now we're moving on and we're going to get into some advanced widget concepts. Now, the widgets are typically the ones that are holding some kind of state. So for example, your text input, your buttons, those are what I'm kind of referring to with widgets. Things like the data input or rendering a title, for example, that's not really what we're referring to here. We're referring to the more dynamic pieces or elements of our UI. For example, typically the ones used in a form. So what I want to do is explain to you how widgets work on a lower level so that you have more control over them and you know what's happening, especially if you're building something more complex. So first, let's look at something that's not necessarily intuitive. So let's make two buttons and let's give these buttons the same name. So we're going to say st.button and that's okay. And then st.button and let's go here and do okay again. Now, when I run this, notice that we actually get an error. It says Streamlit duplicated element ID. There are multiple button elements with the same auto-generated ID. When this element is created, it's assigned an internal ID based on the element type and provided parameters. Now, this is an important thing we haven't yet looked at. All of our widgets, things like buttons, text inputs, etc., they're going to be given a key or an ID. Now this is going to be automatically generated for them, and it's going to be based on the type of the element and then any parameters that we pass to it. So things like the name or things like the maximum input, pretty much anything that we pass to the button will be used to derive its ID. Now in this case, we have two buttons that are exactly the same. They both say okay. Now Streamlit identifies these buttons as the same button. They have the same ID or the same key because they're the same type and they have the same parameters. So that's why we get this duplicate ID issue. And if we want to fix that, we need to manually pass to this a key, okay? So I'm going to say key is equal to btn2, for example. And now if we run this, everything's okay because we have a unique parameter here that allows us to derive a unique ID. So every single widget uses this kind of key or its ID to kind of store its state. So what really ends up happening is when I press this button in the backend, we go and we update a piece of session state using the ID of this button as the key for that state. So I press OK, we rerun, we update the session state so that the button now is equal to true. And then when we have the return value from the button, we retrieve that from it in state. So when two buttons have the same unique ID because they have the same parameters passed to them, we get an error in our state where we can't uniquely identify these buttons. Hopefully that makes a bit of sense, but these keys are used to kind of uniquely identify these and allow us to have that unique ID in the state so that we can keep track of all of the state associated with these buttons. Same thing for text inputs, same thing for any elements. If you have the exact same parameters passed and they're the same type, you're going to get that duplicate widget ID. So it's a good practice to be adding these keys manually to your buttons so that you can identify them and they don't end up having the same ID. Now, along the same lines here, if an element or a widget's parameters are changed, so is the state of that widget. So let me kind of show you an example of that. What we're going to do is just make a basic slider. So we're going to say minimum value is equal to st.slider, and we're going to say set min value, and we're just going to pass 3 values, 0, 50, 25. Okay, now let's add another slider. We're going to say slider underscore value is equal to st.slider. We're just going to call this slider, and we're going to take the minimum value 100 and then the min value. Okay, so if we refresh this here, you see that we have a slider. It's going to have 25 minimum value, 100 maximum value, and then 25 is the default. And then if we looked at this slider, it's 0 minimum, 50 maximum, and then 25 is the, the default, or what we start at. Now, if I move this slider around, you can see I can go anywhere from 25 to 100. I can go up to 90, for example. And right now, the reason why this is being kind of maintained is because we have some ID for this slider, and as we update it, we change in the session state this value. Okay, so we go to this slider, we use its ID, and we set, the ID of this slider, the value associated with it is equal to 84. So as I move this around, you can see that we kind of update and we retain that value. Now, the ID of this slider is generated from these parameters, from the name, so what we have for the label, from the minimum value, maximum value, and the default. But what happens if this value changes from something like another dynamic input? Well, watch this. Boom. When I change this to 34, notice that my slider now gets reset. It didn't maintain its original value. So as I change this, my slider is going to keep changing. And the reason for that is we now have a new session state, or a new ID in our session state that's storing the slider. So again, if I go to something like 68 and then I make the minimum 29, it just gets reset to 29. Now that might intuitively make sense to you, but it's an important thing to call out because it proves to us that this slider is identified by its parameters. So if we wanted to fix something like this, we would actually need to store the value of this slider in our session state. So let me show you this. I'm going to say if slider not in st.session underscore state, then we'll say st.session underscore state dot slider is equal to, and let's just give it a value like 25. Now, rather than the default being the minimum value, we're going to say st.session underscore state dot slider. Okay. And then we're going to, rather than saying slider value, we're going to say st.session.state.slider is equal to this. Let me make it smaller so you guys can read it. But what's going on here, a little bit, let's make it like this, is we say, okay, we're going to check and see if this is in the session state. If it's not, we're going to add it and make it equal to 25. Then we're going to render this slider. We're going to set its value equal to that we're storing ourselves in the state. And then anytime we change it, we'll update the state to hold that new value. So now if I refresh this and I set the slider to 80 or something, and I move the minimum forward, you can see that yes, the slider looks different because we're changing the minimum, but its value is being maintained. Okay. So that's an important thing to understand, is that we get kind of a new widget where its state's going to reset. So if we're trying to dynamically update the values of the widget or the parameters we pass to it, then we've got to store its value in state if we don't want that to be reset or to change. All right, so now we're moving on to another important concept within widgets, and that is that if a widget is no longer rendered on the screen, its state is destroyed. So what we can see right now is that we have some checkbox, okay? With the checkbox, when we press it, we're gonna call this callback function, which is gonna change the state to be like, true or false. So we're just storing the check state here in our state so that we can use that here to display a user input box. So pretty much that means when I press the checkbox, we show this. When I uncheck it, we stop showing it, and it happens instantly rather than needing to run 2 times because we're using the callback. Okay, so here, if I enter something like Tim, you can see that the user input gets updated and we show Tim. Okay, that makes sense. We're able to write the user input down here. However, what will happen is if I uncheck this, the user input will still be equal to Tim. That's fine because we haven't removed it from the state. But if I run this again, notice that now the user input gets cleared. Now, the reason why that happens is that when we stop rendering a component, we remove its kind of internal state from the session state. And when we create that component again, it now has a new state and it gets cleared. I know that's a little bit confusing, but again, look, I type Tim, right? And then I make this field disappear. Now, when the field reappears, it doesn't still contain Tim. You would expect that it might do that because we're just kind of hiding it and showing it. But the way that Streamlit works is that whenever we have a component that's no longer being rendered on screen, we actually remove its state. So kind of behind the scenes, what's going on is all of the internal state, the stuff that we're not managing ourselves, it will kind of compare that to whatever's on the screen. And it will say, okay, well, if we have some state and it's not being used on the screen and we're not kind of manually handling it ourselves, we're going to remove that so that we're not storing stuff that we don't need. Now, the reason this is problematic is that I now need to kind of cache or store this state myself if I want to make sure that whatever's in here is maintained across me kind of toggling this checkbox, right? So again, I type Tim, okay, user input's Tim, that's fine. When I close this, user input is still equal to Tim because we haven't changed this user input session state variable yet. But when I tick this again, we now see that, okay, we should render this. We render it, but now it's a new component, not the same component as before. So now its state is empty. So we end up setting the user input state to be equal to nothing. So the way that we need to fix this is we need to set the value here to be equal to whatever we had in the state. So if we say value is equal to st.sessionState.userInput, now what will happen is let's go here and say Tim, and then close this. And then when we reopen it, it's still equal to Tim because it grabs that value from the state. It doesn't hold that previous value unless we manually set that, because Streamlit sees this as a brand new component, not a component that was kind of hidden and reappeared. So maybe that's obvious to you, but something I wanted to point out because there are some kind of important things to realize about how components and widgets specifically are rendered, how they store their state, what happens when you hide them or destroy them and then recreate them. Anyways, that's it for advanced widgets. Now let's move on and talk about caching. So now we're moving on and we're talking about caching. Now, as you've probably realized at this point, what's going to happen is we're going to have a ton of different reruns of our Python script. And that's not necessarily efficient, especially if we need to reach out to something like an API, or we need to grab some data that might take a long time to run. So what we can do within Streamlit is we can implement a cache. Now, this cache is something that will be hit for every single user across every single session to save us a significant amount of time. Now, what you first need to understand is that Streamlit operates as its own web server. So yes, it's rendering our Python code, but it's doing more than just that. It's serving this code to a bunch of different users. And if we deploy a Streamlit application, we have that kind of central web server. Yes, it's rerunning this script and it's doing it for multiple users, but it's able to reuse functionality and, for example, use a cache for all of the different users of our application. So what I'm going to show you in this simple example that you can see is how we implement a basic 60-second cache to kind of avoid having to constantly hit the same endpoint or the same kind of slow running operation. So you see that we have some function fetch data. Imagine this takes a fairly long amount of time to run, and you don't want to run this for every single user, maybe hundreds of times per second, depending on how many users are using your app. So what we can do is we can set up a cache. We can say at st.cachedata. This is a decorator built into Streamlit. We can specify how long we want this cache to survive. In this case, we can do it for 60 seconds. We can also just have a permanent cache where we remove that. So now if we remove that, this cache is just indefinite. Unless we manually clear the cache, it's just going to exist forever, which in some cases you want. But anyways, we can go back to have that kind of TTL 60. And now what will happen is anytime any user needs to call this function on the rerun of an application, if we're within this 60-second cache period, so if the function was called within 60 seconds, we'll simply hit the cache if the arguments to this function exist in the cache. Now, what that means is that right now, we don't have any arguments to this function. So pretty much we'll only ever run this function at most one time every 60 seconds. Because again, if it's ran, we then cache the result from it. And then within 60 seconds, if someone tries to call it again from their own client, then we'll just use the cached result and have instant access to whatever this data was. However, if there was an argument, like argument 1, argument 2, Streamlit will cache the function call with the arguments, which means we're only going to hit the cache if we call the function with the same arguments that someone else has called it with. That way, if you pass a unique argument, we will actually run the function to make sure we get the correct result. Now, again, the point of caching here is to make sure these slow running operations don't need to kind of constantly be reran by multiple users, especially because when we write in Streamlit, we're not really separating out the front end from the back end. We kind of have all of this meshed together. So it's just a different way of writing code, and that's why we've implemented this cache. Now, cache data itself is used when we want to have immutable data. So in this case, we're returning a Python dictionary. This is a mutable type, but when we return it from this cached function, we kind of make it immutable. That means that if we modify this from outside, so wherever we're using this data, it's not going to affect what's returned from the cache. We're always going to get like exactly this. So even if we modify this resource outside of the cache, we're still just going to get this on every single cached call. Now, there's a way to cache a resource, which is mutable, which we'll look at in a second, but I want to show you how this works. Okay, so let me save this and refresh. Now notice on the first run here, we actually run fetch data, okay? So it takes 3 seconds to run, and we say st.write, fetching data, we wait for this to run, and then we write out the result. Now watch what happens if I refresh this again. Notice we don't need to wait 3 seconds. We just instantly get the data. The reason for that is we're within the cache period. Now, even if someone else on a different computer goes to our Streamlit application, they're going to be hitting this cache as well. So they're going to instantly get this data because the cache is global for every single user across every single session. So pretty much you use the cache, especially this specific type of cache, whenever you have an expensive operation that you want to make sure is kind of more efficient for users. You can set a time limit, you can pass different parameters, and you can cache as many functions as you want, and this can significantly increase the speed of your application. Now, we also have another example I'm going to show you here, which is the cache resource, okay? This one's coming from ChatGPT just to save us a little bit of time here, but I'm going to explain how the resource works. So previously we were using cache data. Now we're using cache resource, which allows us to have mutable kind of values returned here so we can modify what's going to be returned from the cache. In this case, what will happen is the cache will actually return a reference to the particular resource rather than the resource itself, which allows us to make modifications to the underlying resource that will then be affected for everyone that hits the cache. So when we're caching data, it just gives us kind of like a new copy essentially of that data, so an immutable type. In this case, we get something mutable so that if one user, for example, modifies what's inside of the cache, like that resource, it will be affected for every single user. Hopefully that makes sense, but we're just really talking about immutable versus mutable data being returned from the cache. So in this case, what we're doing is we're kind of returning a file handle or a file object. So I'm going to try to open a file in append mode, and if it doesn't exist, we'll create it, and then we'll return that file object. So the reason we're caching this is that rather than having every single user try to create this new file or open this file object, we'll just have one file that every single user shares, right? Just like you would have in your backend. So then we have this file handler. So we say, okay, we're going to get the file handler. We're going to hit the cache every single time except the first time this is ran. So every user is interacting with that same file. Now, if we try to write to the file, so if we press a button, again, we use this cached file handler. We can write to it. We can flush this, and then we can write, okay, this was successful. And then same thing with the read file. We can seek the beginning of the file, and then we can read the contents. Again, using the cached file, we're not having, millions of different file handlers for every single user. We're using one resource, and the reason we used a resource here is because we're actually modifying it, right? We're changing the seek head within the file. We're writing to the file, we're reading to the file, so we're modifying that underlying resource, and all of our users are sharing that. So if we refresh here, we can write to the file, okay, we can read the file, write to the file, read the file, we now have 2 lines, and we can of course close the file as well. Okay, so that's it for caching. Obviously, there's a lot of great examples when you'd want to use that, and keep in mind the difference between cache resource and cache data. So now I want to move on to talking about a manual rerun. Now, this is something we can use to force the app to rerun, which can solve a lot of the problems we saw previously. Now look at this example. We just have a simple counter. We want to have a button that increments the counter, and we want to do this immediately. But look at what happens right now. When I press the button, the count doesn't update right away. it requires another press or another rerun to actually get up to speed with the count, and it's always lagging behind by 1. Now the reason for that is the way that this is written. Again, we have this, if st.button, so if this, then we're going to increment and rerun. Now we haven't implemented the rerun yet. I'm going to show you that in a second. What we do is we add 1 to the count, but we're displaying the count before this button. So we could put the button before the count, but what if we want to display the count before the button and we still want this to work properly? Well, what we need to do is we need to rerun the application manually a second time so that the count gets updated immediately. So again, let me just run through this slowly. We check, okay, is the count in session state? If it's not, we add it. That's fine. We then have the button, but remember, when we press the button, the first thing that happens is we rerun the app right away. So we start rerunning, we display the title again, we check this, and then we display the count equal to 0. Only after we display the count do we come here and run this function, which then increments the state. So the state's updated after we're displaying the count, so the count's always lagging 1 behind. So what we actually want to do is after we update this, we want to rerun instantly so that we then get that update without having to press the button twice. So what I can do is inside of this function, I can write st.rerun, which will manually invoke a rerun, which will then update the state for us. So now let's refresh and run, and notice that the count actually stays up to date, right? The first time I press it, it goes to 1. Now it does require 2 reruns to get there, but it gets there because we can manually rerun instantly at this point. So yes, okay, we get to the button, we increment and rerun, st.state gets updated. But usually if we didn't have this, we'd have to wait for another rerun before we see that. In this case, we manually rerun at this point, and then we see the update. Okay, that's an important concept. Now let's move on and talk about fragments. So now we're moving on to fragments. Now fragments are a way that you can rerun only certain portions of your user interface, and you can better organize and kind of separate out your code. Now, what you're seeing here is 2 fragments. What we've done is defined a Python function. We've decorated it with fragment. And this means that this is a UI component that will run independently from the rest of our application. Remember that anytime we do something with a widget, like change the text area or the toggle, it immediately reruns our app. However, a lot of times we don't want to run the entire application. We just want to run the part that's affected by that particular change. So what we can do here with this fragment, for example, is we can limit reruns to this scope, to this particular fragment. For example, when I click the toggle, the only part of the application that's rerunning is this fragment itself. We're not rerunning the rest of the app. It's just this particular fragment. Now, same thing with this fragment here. So if we go to where we have filter down here, when we do this, yes, we're rerunning, but we're not affecting the other fragment or anything outside of that particular fragment. Now, when we do change something outside of the fragments, so something like this select box, then that will affect the entire application because that's not defined in a fragment, but these 2 fragments here only rerun within themselves. Now, you do have the ability to trigger a rerun outside of the fragment by doing something like st.rerun. Okay, and then you can say, I believe there's parameter that you can pass here. Yes, you can say scope is equal to app. And if you say scope equals app, then what that will do is rerun the entire application. But if the scope is fragment, which is the default, then what it's going to do is simply rerun this particular fragment. So if you have something like a dynamic slider or something that does need to change based on the value of another widget, you can put that inside of a fragment, just that dynamic content part, and avoid re-rendering other parts of your application. So this is really a massive efficiency gain. Now, there's a few other ways you can use fragments. I don't want to get too into it here because this is a more advanced feature, but the point is, if you want to do kind of some dynamic update, wrap it inside of a fragment, and then you can simply just call the function where you want to render this part of your UI, and now you've limited that re-rendering to this particular fragment. Again, you can affect outside of the fragment from in here if you want to do that. If you do that, then that is going to trigger the rerun of the entire application, but this allows you to isolate dynamic content in one part of your UI. Now, one quick note here, if you're using a fragment, you can't return data from it. So I can't do something like, return hello world. I can write that, it's not going to give me an error, but it's just not going to do anything in my program. So if you want to share data between the fragment and outside of it, you need to use your session state. So I can use st.session_state, and then I can kind of globally access that from wherever I want to, but I can't return a value, for example, to the function call. That's just not going to work. It's not supported in Streamlit. So just a quick note there. Anyways, you can read more about Fragments from the documentation, but it's a great way to separate out different UI components, especially when you only want to kind of isolate the re-rendering to that particular portion of the UI. All right, so now we are moving on to multi-page apps. Now, obviously at some points you want to have multiple pages, you want to separate your code out. So let's look at how you do that. Now, the names of your files are actually going to be what Streamlit will use as the page names. So for example, my main page, I'm going to call it home.py. Now inside of here, we can just say import Streamlit as st, zoom in a little bit. And what we can do here is just write like a title, st.title, and something like home. Now what we'll do is we'll make a directory called pages, and inside of pages, we can define additional pages that we want for our application. So what I can do is say 1 underscore, and then page1.py, and then I can say 2 underscore, and then page2.py. And what I'm doing is defining the order in which I want my pages to exist. So the page1.py after the underscore, that's like the name of the page. And then the 1 and the 2 defines the order within my page list, which you're going to see in a second, where my page will be placed. So I'm going to copy these and just paste these in and change this to say, page 1 and page 2. And again, make sure this is in a pages directory. And now if I run my home app, so I say, Streamlit run and then home.py, what you're going to see here is that we get home and then page 1 and page 2. Okay, so it's looking for our pages automatically, and when we click into them, we have the various pages. Now, a few important things here. If I go to page 1, for example, and I say st. For example, text input, something like name. So let's add that and refresh here. You'll see that if I type something like hello, and then I go back to page 2 and I switch back to page 1, you see that content disappears. So as soon as the page is re-rendered, all of the state will be destroyed. So you need to manually store that in st.session_state if you want to have that persist through the different page presses. Now, obviously you might not want, for example, page 1 to be the title of the page at the top. So you can change that. So on each page, you can go st. and then you can say set page config. And you can pass to this the page title, which is what you see at the top of the page. So something like, new page. And you can actually pass an icon as well. I'm not going to do that now, but you can. So if I refresh this now, you can see that it says new page. And we can do that for all of our pages if we want to change what appears here. Now the label, at least to my knowledge, can only be set through the Python file name itself. There's another way that you can define pages, which I'm going to show you in a second, but at least in this way, you've got to just change the name of your Python file if you want to change the label in the sidebar. Now there is other ways to define these pages and to navigate in the pages, and I'm going to show that to you now. So let's say we don't want to use this method. Let's delete these pages. Okay, and let's just go to home.py. And let me show you another method to define pages. So the way that I showed you there is kind of like the native built-in way, but you can also do pages kind of like this. So for example, I have some functions like an intro page, a plotting demo, a mapping demo, a data frame demo. You don't have to worry too much about these, but they're just like part of the UI. And then what I can do is I can map, for example, a dictionary with page names to different functions that I want to render. Then in my sidebar, I can create a select box. And that is going to actually show all of my different page names. And then what I can do is simply just render the appropriate page. So this is not, the official page way, but this is one way that you can do it. And if I go here, you'll see that I can now select on here. And when I select on it, it's going to render that function. Okay. So you can see that that is now working for my different pages. Now that's not like the native built-in way to go about doing it, but it is one method. What I'm going to do now is I'm going to go back to the previous example, and I'm going to show you the ways to navigate between the different pages, but I wanted to show you that this is also an option. And from here, now you kind of have your own custom router. And if you want to change the page, you just change the selected page variable, and it will render the different part of your UI. All right, so I'm just on the documentation here because the multiple page apps get a little bit confusing, and it's going to take me like hours to explain all of this. So I'm just going to kind of direct you to here in terms of how to do it based on what you want in your application. So I'll link this in the description, but you can just find it very easily, streamlit.io, and you can go to multi-page apps. And you can see that there's many ways to create more advanced multiple page apps. So if we look at the first one, this is kind of what I was showing you before, where we have pages and we have kind of a list of the different pages here, and the order in which they appear is the order in which we'll display them. It's talking about, setting the title, the label, all that kind of stuff, which I talked about. And then we have, for example, automatic page labels and URLs, and it kind of just walks through how all of that works, which is what I explained. Now, in terms of switching pages, you can see that there's this command st.switch_page. So if you go here, all that it takes in is the name of the page. So it can just take in a string, which is like the page name here. So whatever the pages/page name is, that's how you can switch between it programmatically from buttons. So pretty straightforward, but there's also a lot more advanced ways to go about doing this. So you can use switch page, but you also can define like kind of custom navigation routers. So for example, if we go to page and navigation here, you don't necessarily need to put all of these pages inside of the pages directory. Instead, you can make your own router yourself by defining st.navigation and then placing different page objects that reference different Python files, and that can be your custom router. And then you can run that with pg.run. So that's kind of what they're showing you here. Now you also can define your own custom pages, which is what they're doing here with this page object, throwing them in the router, and then they're again kind of setting a config for this particular page. Keep going, you can customize the navigation, setting page links, etc. And you can add multiple pages that are nested inside of each other. So you can have a reports directory, a tools directory, and now if we go here, you can see we have, for example, dashboard. We have all these pages that we're creating, and we're making this kind of nested navigation structure. So I don't want to explain all of this because it just really depends on the type of app that you're making, and the documentation is pretty clear, but I wanted to quickly go through it and kind of just show you what's possible. So again, you have like pages directory, you can nest directories, there's just a lot of stuff going on here, and it would take a very long time to cover all of this in the video, and most of it you're not going to need to know. So anyways, guys, that is going to wrap up this Streamlit course. I know this didn't cover literally everything in the documentation, but I think it's a pretty good starting point and at least teaches you the architecture and the main theory. So now you understand how to build these apps, things like state, caching, fragments, which are really important. And once you understand, you can really go quite far with this framework. If you enjoyed, make sure you leave a like, subscribe to the channel, and I will see you in the next one.